All right, so we're back. So we're doing another live stream, and today we're gonna have a little bit of a shorter stream, but should be able to go on for a little while. To start off, my name is Cecil Worsley. If you haven't tuned in before, I'm the founder of a company called Wrecking Ball Systems, and we do safety orientation management for commercial construction job sites. We build software and hardware around this particular issue, and we are starting it's a startup, so we're starting from scratch. We have started from scratch, and we are continuing to improve the products that we offer today. And the main product that we offer is called Safety Now, and it is the system that powers the safety orientation software. It powers our facial recognition check-in software, um, et cetera, et cetera. So as we get more into it, we'll explain more about what the company is and what it does, and how it works, and so on and so forth. But today we'll be working on a little bit of our hardware. We have to do a little bit of maintenance later this week before we are off for the wedding, which is in 4 days. Um, we have to go up to the job site's about 2 hours away from where we're located here in Wilmington, North Carolina, and we need to do a couple of things. One, we need to replace it with a fresh battery, which we shouldn't have to do. But there's a reason we're having to do it, and that reason is what we're here to do today. To give a little bit of a background, and we'll see if I can show it here. But we have out in the field on our job sites, we have these custom kiosks that you can see here. And now it's not on at the moment. But this is an Android-based tablet, and it's got everything from Bluetooth, Wi-Fi, cellular connectivity. It's got obviously this large touchscreen on it, and it's a kiosk. So when you walk up to it, we use with our custom app, we do facial recognition to identify a person. So we identify that they're there, and then when we feel confident enough that that person's there and it's there for the picture, so they're still enough, then we snap an image. We send it to the back end to do some facial recognition and then return the result, giving them a status of, okay, yes, you were checked in. Excuse me. Yes, you were checked in. No, you weren't. You need to complete the orientation if you haven't already, et cetera, et cetera. So that's primarily what this does. But in some certain situations on commercial construction job sites or on just job sites in general, we have a terrible issue with there not always being electricity, so you can just go and plug something in every time. And that seems kind of obvious, saying it out loud, but what we've done is we've gotten some hardware together that we've manufactured, and we have solar panels. So the solar panels will get their energy from the sun in the way that they work. And then it will go down to a converter that will charge a 12-volt battery, like what you'd find in a car. And then from that 12-volt battery, you can connect a load to it. So in our case, that would be this tablet. Now, these tablets are not exactly energy efficient because the expectation is that they're plugged in to a wall. So there's really no need, I suppose past Android being, part of a phone that has a battery in it, so on and so forth. But anyhow, one issue that we have is that they do not turn off at night. So they sit up all night and they're sitting there and they're looking for people and they're looking for people, but there won't be anybody for, 8-10 hours at a time. Or, when they take off work on Sundays, there's nobody there for probably 36 hours or so. So we need a way to make sure that these things turn off appropriately. Now, fortunately, we have a custom battery management system that you can sort of get the idea of up here on the screen, and I can actually show you a picture of it. This was all built in-house because there's really not anything on the market that fit our needs. At least not in the way that was affordable, something that we could quickly integrate or get a hold of. So we had to build our own. And it's a pretty simple circuit. It's got the Arduino Nano as its microcontroller. And what it does is it takes input from a few different places. And actually, I can show you a very incorrect yet crude example of a carrier board that we're developing. That'll make this whole process easier. So it's got a relay, which will be this piece up here, and that is basically a light switch if you're not familiar. So you would plug in your load or the thing you're trying to power here, and then this is the switch that'll turn it on and off. This is the power input that'll power the entire device. This is a voltmeter. It's not incredibly accurate, but it's accurate enough for our needs. These are just parts you can pretty much get on Amazon for $0 or very cheaply. And then this is a Bluetooth module that we can talk about a little bit later. It's the H6, no, it's not written on there. HL06, I want to say, or the HC06. Anyhow, they're pretty common, and they're essentially a serial relay. So you would send serial data from here to something like this Arduino, or the Android tablet that we have here. And then, we've got some transistors and some resistors here, but then this is where the Arduino sits that you can see on screen. And it would sit in like that there. So that's what powers the whole thing. So we look for a few things. When we're taking the voltage of the battery directly, the 12-volt battery, and don't quote me on this, but they've got, an operating voltage between, 13.2, give or take, and you can look it up, down to probably 11 volts. And that's kind of where you want to cut things off. So to prevent any over discharge, we don't have to worry about overcharge, because that's what the solar MPPT controller will handle for us. But we don't want to over discharge it. We don't want to keep pulling it, because we're pulling everything that powers this directly from the battery. We had to bypass the MPPT controller. Reason being is that it just simply couldn't handle the amperage that this was apparently pulling, which seemed a little bit suspicious, but there's a lot of Chinese parts involved here, so things aren't always as described or as advertised. So anyways, we're pulling a load directly from the 12-volt battery, and so because of that, we want to make sure we don't over discharge it. So we use this here to measure the voltage, and if the voltage ever gets too low for too long, then we will just cut the whole thing off and take another look in a few minutes later. And if everything has kind of come back online and it's sort of stayed at like a good constant voltage, meaning probably that the sun is out and the solar panel is charging the battery, then we can turn things back on. So this is sort of a carrier board that manages power for a 12-volt battery that gets charged by a solar panel out in the world. Now, we kind of got lucky here for a couple of different reasons. We didn't intend to do what we're going to do today, but because we can turn the tablet on and off via the switch here, we can turn it off, at night. So it's a little bit difficult. It's a little bit difficult to just find an API, for example, and turn a tablet off. Like if you're writing an Android app and you want to turn it off manually, you can't just do that. You've got to sign the app as a system app, like system level, so it'll give it some increased permission levels, and then you can kind of do it, but even then you need to turn it back on. And then there's some firmware here that will allow you to turn it back on at a certain time, but I've seen issues with, the watchdog clock drifting, being inaccurate, and I just want to get something a little bit more surefire. Because the device is out in the field and it's hours away, we don't really have the patience, not the patience, but the ability to take any chances. So, for right now, if this device were to get powered off, I don't believe there's an internal battery that will keep time. So if you have it turning off, let's say at 8 p.m. and then turning back on at 6 a.m., and if the power ever gets cut, then it's going to lose track of time. So it won't know when to turn back on when it eventually does get power back. So we just don't want to rely on that. I've done it in different systems. I've tried to do it in different systems. And unless you put like a lot of time and effort into that specific thing, then there's just a lot that can go wrong. So what we are going to do is we're going to allow the Android app to turn this off, to turn itself off. So it will send a signal via Bluetooth to this controller board here, and it will cut the power. And then at that time, the Arduino will keep track of time crudely because it's not, it doesn't have a external clock with its own external battery that we can control, but it should be fine. So we should be able to count to, an hour. And then when that happens, we'll turn it back on. When the Android tablet gets connectivity again to the internet, and it will sync its NTP, sync with the NTP server to get its time, and it needs to go off. It turns out it needs to go off, then it will. So that's what we're going to be working on today, since we will be deploying this later this week before we go off for the wedding. So I'll kind of explain everything again as we get going, but let's take a look at what we have today. You can see that this is, and I can bump up. Well, let's see if I can increase. Let's see, there we go. And I want to, let's see, drag these things a little bit so you can see better. I'll kind of show you some of the idea here. Oops. There we go. Better. So this is a potentiometer, and it's basically just a slider that will represent some sort of value. And for our example today, it'll be the voltage of the battery. So so we can slide and adjust that to sort of simulate the discharge of the battery, and then we'll have the Arduino react. And this little LED here, which you would add a resistor to typically, but this is just a simulator, so it's really unnecessary. It will turn on if the Android tablet is going to be on, and then obviously off if it's going to be off. Now, this is some of the actual firmware that we use, and by some, I mean pretty much all of it. We've just sort of polyfilled, if you will, some of the components we use in the real world. Now, I would love to show it to you on real hardware, but the way the streaming setup is, we just don't have it here, and sometimes it's just easier to keep it all in software like we have right now. So before we get too far down, let me actually make sure that the stream is working. Just going to pull it up and make sure we are looking good. And now this website that I'm using over here is, I guess it's called Wokwe, I guess. And I think there's a lot of simulators out there, but this one's been good to me, so we'll keep using it for now. Yeah, I mean, there's not too much you can do with it. There's not too little you can do with it. It's easy enough to get started with it. Okay, good. So we're live. Just wanted to make sure. So let me show you how it works today. And hopefully, yeah, okay, we can clear that. I went ahead and got it set up, so we have to go through that process, but it's pretty plug and play. Now we can see right here, well, let's pause for a second. So what we do in the setup is, we start serial, we set our baud rate. We set the baud rate for the Bluetooth device that we have connected to it. And that's not really going to come into the equation here because we're not dealing with Bluetooth today. But we read serial just like we would anything else. We've set pin 3 as output, and pin 3, it's hard for me to see here, but yeah, pin 3 is our load. So that is us turning things on and off, turning the tablet on and off in our case. We're getting a start time so that we can do some math later on down the road. And yes, that is a global variable. Yeah, right there. Now, I'm not a C++ pro by any stretch of the imagination. I can get the things done in Arduino when I need to. So we try to keep things nice and simple and light as we can. And this is certainly the biggest project I've ever done in the Arduino world. But our device and our stuff has been out there for maybe 5 or 6 weeks now. And so it's been going really well. So we want to kind of continue down that and not have to go fix things later on, especially as we're going to be out of town for 2 weeks. So this is sort of a dangerous operation. If things go really well, then we'll deploy it. If not, then we'll just keep calm and move on. Let's see. So the first thing that we would do in our loop, if you're not familiar with Arduino, there's 1.5 million YouTube channels out there that talk about what it is and how to do it and how to program for it. This is not that channel. This is just showing me build my company and how that process goes. And hopefully it will help and inspire all of you to go out and do the same. So anyways, the first thing we do in the loop, that's going to loop, as fast as the clock or the processor will allow it to. So we're going to check if the kiosk is sleeping. And if it is sleeping, we're going to take a look at the wake time. So if it's time to wake up, then we're going to wake up. We're going to turn the kiosk on, and then we're going to get out of there and do this all over again. Now, we're saying kiosk is sleeping. That's false. So we will not enter into this again, into this branch of the code. And if it's not time to wake, then we'll just say the kiosk is sleeping, and we'll continue to check and check and check until it's time to wake up. Check voltage. There's a method down below that handles check voltage, which is essentially doing a little bit of math on an input from this component here that we looked at earlier. And this is just an analog input. We do a little bit of math to kind of normalize it to a voltage, whatever the voltage is determined to be. And if you're curious, like making one of these voltmeters or voltage sensors, they're really easy to do. It's really just determining resistance is how I understand it. Obviously, it's easier to buy this little component off of Amazon than to go build one yourself, but either way works. So yeah, here we're going to do a little bit of, we're going to take it from, I think, a double to string, and then we're going to format it so that we can print it out and we can send it Bluetooth. Because what we'll do is we'll take the voltage, we'll send it to the tablet, and then the tablet will capture that input and then send it to the backend server so that we can always know what the voltage is, so that we kind of know how much juice we've got left out there. So in the event that it's sort of dwindling down like it has been for a little while, we'll know that we need to go up there and do some maintenance and kind of come up with some power saving schemes. One way we save power today is that, and we have some code in our Android app, to put it simply, where we can adjust the brightness remotely. So at night it will dim all the way down, and then obviously come back up in the morning. So here we'll sleep for a second. We handle BLE commands. So there's some commands that Bluetooth can send down. We'll have to come into this method a little bit later. So essentially the tablet, what it's going to do is it's going to send us a command that says, I'm shutting down. So it says, turn me off, basically. Here's where we're kind of calculating voltage. So, or where we're sort of inspecting the voltage. So the voltage is less than 9.5, which is like an absolute minimum. You really don't want to go much further down than that. In fact, you don't want to really go further down than probably 10.5. And I'm roughing out these numbers, so don't take it as law. Just go and look up sort of the discharge charts that you can find. In fact, we can pull one up. 12 volt discharge chart. So yeah, I mean, and now I'm not really sure where this is from, but it's probably not too far off. Different people have different opinions. So yeah, you're kind of in the danger zone when you hit 10.5. Now I happen to know that the math is not perfect on this voltage sensor, so I know it's about a volt off. And that's kind of why we went down to 9.5 there. So when it gets down to below 9.5, or the discharge rate and the discharge rate is less than 10. So that's we had this discharge counter. So for every time we loop, if it's below the threshold, if it's below 9.5, we increment the over discharge rate by 1. So if it's still below 10, so so if it's below 10, then we'll increment it. If the discharge rate is greater than 0 and the voltage is greater than 9.5, then we will decrement it by 1. So we sort of keep this sort of like floating threshold and counter to determine what we want to do. And we determine that later. So if over discharge count is above 10, and let's see what disconnected. I'm actually not sure what disconnected is. Let's see. Disconnected. Oops. I think disconnected means that it's turned off or that the kiosk has been shut down. Yeah, I think that sounds right. So if we've been in an over discharge state for more than 10 cycles and we are not already turned off, then let's go ahead and do that. So we're going to go ahead and tell the device here that it's going to shut down in a second. And I think the idea here was that we would delay for 10 seconds. So we're going to go ahead and tell it to shut down. That way you can contact the backend server, say, hey, we're going down. That way we can send an email so that I know it's not just randomly turned off because we got run over by an excavator or some other ridiculous reason that I'm sure will happen one day. Yeah, that way we can alert ourselves. And then we'll just turn the kiosk off, which is essentially just setting the pin low. On the relay, so the relay will disconnect. So if the discharge count is 0, so we probably, now we're improving the firmware. It's not super well tested. We put this whole entire product together in 10 days, so there's plenty of error. So if it is disconnected, if it is disconnected and the discharge count is 0, then disconnected is false and turn the kiosk back on. So that means for 10 cycles, we have determined that we are above the over discharge threshold. So now we can turn things back on. That's probably not long enough because a cycle, ignoring all the operations that it does, a cycle is like roughly 20 seconds. So if you 20 seconds times 10 is like, oops, probably obvious answer is 200. So that's 3.5 minutes. Probably not long enough. Probably not long enough. So we could probably do some adjustment here. Probably do some adjustment here. I've turned off this delay for now, just so that we can kind of get results a bit faster. And then it sleeps. So this is the end of the loop. We're just gonna like not do anything for a little while. We don't want to charge pull more power than we need to, and we don't need to look at these values all that often. They're not that incredibly critical. So, anyways, that's kind of how it works. Like I said, turning on and off the kiosk is just writing to a pin high or writing to the pin low. A quick thing that we can do is this digital write 3. We can probably set this to a constant up above, so maybe like load relay pin like this. And that way we don't have, if we ever want to change that pin, we only have to do it one place. And I think we do it up here a little bit. Yeah, here we go. Or we set it to output. And so here we can just do, there we go. It's good enough there. And let's sort of just run through the simulation real quick. So I'm going to get rid of that output. There we go. So again, the sleeping is just temporarily low. Discharge is at 11. So let's turn the voltage all the way up. So now you can see a voltage here. If we pause, the voltage right now is 14.44, and that won't happen in the real world because there's a controller external to us that manages that voltage. But all that it needs to be is above the over discharge threshold. So you can see our over discharge is going down. So 3, 2, 1. And so here we go. So, oh, now we're recharged. Now we're going to turn the kiosk back on, and you can see our LED here turn back on, our LED again representing our Android tablet. So that's good. That's what we expected. And again, over discharge never goes below 0, so that's good. It's going to constantly say we're in a recharge state. Turn it on, turn it on, turn it on. Right, that's good. So let's say what we probably need to do is set, at least in this simulation, we need to, let's stop it, for example, or oops, for a minute, and let's create a button or add a button. Now, it'll take me a second to get this all situated, because these are not really well labeled. So like, what the hell do they mean? In fact, I'm going to save this. I'm going to get a new project just so that we can get that button working really quick. I should have done it before, but I didn't. Because I would just go to my projects. Oh, okay, I've got a button here. Actually, I did that before. Because I believe I was simulating this. I've done a little bit of the work already, so we can jump into this. And again, this is just sort of a proof of concept. Let's restart. Okay, so it says hey, so we just print hey to say that it's running and it's working. We're delay every second. So start. So digital read 3 is equal to 1, so saying that it's on, right? 1 or 0, on or off. Then you fall into this branch and you say count from 0. So you set some variables. Start is true. So then if start is true, well, let's just see what happens. So we'll just press the button. Now, a button normally in the Arduino world would probably be set up as an interrupt, but this is really just a proof of concept, and it's not going to actually be a button in the real world, so there's no point in kind of going through that. But I'm sure there's plenty of content on YouTube that talks about buttons and setting an interrupt pin, which essentially just interrupts the loop of your Arduino process, I suppose you could say, and runs a different block of code. So it stops what it's doing, runs this block, and then will continue to run the loop. That way, when the button's pressed, you can set a variable that says button was pressed, and then in your loop, you would do something different, kind of like we're doing here. So I'm just going to hold it down to make sure that when it's looping, when it reads that digital pin 3, it'll notice it. So I'm just going to hold it. Okay, so it started. Time is 1, 2, 3. So let's see. Where do we print this? Oh, okay, so time and then count from. This is the count from variable. So count from is larger than turn on in. Okay, well, turn on in is set to 10,000. So this was set in milliseconds, I figure. So let's just set this to 10. So we don't have to wait quite so long. You could use milliseconds if you just want a greater degree of precision. So if you wanted like half a second, but precision is not important here, so it's just unnecessary. And understanding that this is seconds is just sort of easier to wrap your head around, though milliseconds is often used, so it just is kind of whatever fits your fancy. So let's just rerun it. And then we'll press our button. Now you notice I pressed it and didn't notice it. And that's because the loop, that's because um, the loop wasn't reading that digital input there. So we'll hold it down and you can see it noticed it. That's why you would use an interrupt, right? So that when it's looping and it's not looking for that digital pin input, um, it doesn't miss it. So your button reacts when it's supposed to. So turning on. Okay, so when we hit turning on, or when we hit this bit here, turning on, we set start to fall so that we don't process or run this block again. And then it kind of starts over. Right, so when it reads it again, it'll reset count from to zero, so we can run it for over and over and over again. So this is good. This is exactly what we expect. I guess I sort of forgot, how I had set it up or that I had done this before. Some of it before. So let's look at this button. Again, we don't really need a resistor. This is not that important. I'm going to change the screen up really quick because I think that my camera is really laggy and we don't want that. Just make sure that the screen is nice and clear. We'll switch over to that. So if I kill this and then I will open up the screen, maybe that'll get a little bit better. It looks a little bit smoother. Okay. Okay, so over here on the right, this is kind of our copy or hard copy, if you will, about the firmware for this circuit. So what we want to do is we want to take what we've got here, this simple button example about turning something on at an increment, and then put it into our main project here. So I'm going to pull so we can kind of copy and paste. Again, I'm going to set this as like, maybe they'll let you add a label in here. Let's see. Text. I was going to label these different components so that it's a little bit easier to follow along. But it would seem you're going to have to just be cool with it. So anyways, this looks like it goes to a digital pin. Zoom in a little bit. Zoom in. We'll grab our button. We will take this to whatever digital input we want to use. Again, it doesn't matter because this button does not exist in the real world for us. So we'll set it to digital 5, and then we need to take this to 5 volts, which is here. I know it's impossible for y'all to see, but you'll just trust me. And then this will go to ground, I believe. Yep. So all we'll have to do in our example is, so we've got some sweet spam in the chat, so let's clear that stuff out. Let me hide this so we don't show the spam. Sorry for the interruption, but we can't have people talking about spammy things in the chat. Can't be done. So we will I guess we'll just hide that user. We will remove their messages. Okay, there we go. Sorry about that. We don't have moderators yet because we don't have viewers yet, but we will. We will just in time. Don't forget to like, share, and subscribe. Got to say that, right? That way you can get the notifications and follow along as we build Wrecking Ball up to be a great startup. Okay. Okay, good. So right back to it. So we're going to take this little bit. We're going to set some variables. So, and we're going to name this a little bit better. So here, and we got the beginnings of it, I think. So let's see, how do we want to do it? So start time is fine. Change all occurrences. So start time should be sleep. It's not a constant. Sleep. About kiosk sleep counter. Second counter. Like that. That looks, oops. Okay, that looks good. Or better. And we'll group all these variables. I'm sure there's a way to do multi-file, multi-class, like C++ projects in Arduino, but we're not going to get into that. We'll just correctly use comments and well-named variables as much as we can. So kiosk sleep bars, how about that? Where are we? So we'll set we don't really need to set that. We need to just leave it at 0. Because we're just going to be counting seconds on our own. We don't need to set the milliseconds, I don't think. We can kill that. We can kill that. And we'll leave it in there just for now in case we need to come back to it. We need to set, and we'll say remove before flight, because this is temporary. This is our push button code here. So we're going to do pin mode, and we set that to pin 5. So pin 5 is an input. And that's all we need to do in the setup. Now we'll come down here. And so we got this weird variable start, which is basically trying to say start counting, but we'll be more accurate. We'll say is kiosk sleeping, which is just a Boolean. Move that down here. Okay. So over here we have, if it's sleeping, sleep count, which will actually be kiosk's sleep counter. Is it greater than and we'll rename this kiosk wake up in. It's a number of seconds that we'll wake up in. And then we'll say is kiosk sleeping. We'll just set that to false. This is what we do over here when we turn it on. And if we don't do this, then we will just increment our sleep counter, which will be here. Okay, I think I like that. It's not quite exactly the same, but that's fine. We need to make some adjustments. So like we want to make sure that we definitely return here because we don't, if we're sleeping, there's nothing to check. And so um, there's nothing to do. So we just want to sleep and we want to check back in 1 second. The reason we want to check back in 1 second is because we want to count, we're counting the seconds, right? So it'll return here, it'll fall back down if it's time to, if we need to stay asleep, and we'll just count the seconds. Now again, just because you sleep for a second doesn't mean you're going to get back and count seconds precisely every time. Because between this delay and it calling the loop again, there's all sorts of processes and things that the processor, the microcontroller, is doing. So it's not going to be precise, but it's going to be precise enough for our uses. Now, to prevent too much drift, we don't want to count for 8 hours. Maybe we'll just count for 30 minutes or for 1 hour. So that we wake up. Because if we're going to go and sleep for days, that clock is going to drift over time. So if it takes, let's say, 50 milliseconds to process all this, then it's going to be 1 second plus 50 milliseconds times multiplied by the number of loops that it goes through until it needs to wake up. So we don't want to drift too far out, and we don't want to add a real-time clock external to this project because we don't have that component, and we don't have at this time the ability to change that. We will be doing that in the future, I think, because it will kind of give us some peace of mind as we kind of build a watchdog, if you will, into this. But for now, we're going to keep it simple. So kiosk is sleeping. Let's move this down below. We're going to move this here, and we're going to change this to just print. That means it will not include a new line at the after the print statement. Well, we can leave that. So we'll say serial.print. We don't want a new line. I'll show you why in a second. Kiosk is sleeping. Sleeping or slept for. This is so we just don't have to do like string concatenation, which is like kind of, it seems to be kind of a pain in C++. I think you can do some formatting, like you can do percent %s and str. We're not going through that right now. So slept for will include the number of seconds. Kiosk sleep slept for. And we do want to end with a new line here. Slept for seconds. That way we can kind of keep track and do some debugging about like how long we've been asleep. We could say slept for this many seconds of it's a little verbose, obviously, but getting it done, that's kind of one of our project engineering principles is that we're trying to get things done. That doesn't mean we make a total mess everywhere that we go, but we don't spend unnecessary time on silly things like for just this very basic debugging, which no one else but us will see. Print of the number of seconds we're going to sleep for, which is a variable that we don't have yet. So we need this turn on in variable, which we called kiosk wake up in seconds. So I guess we should just pull this down. And then we can say, for example, say we'll just set it to 10. So 10 seconds will wake up, right? We'll turn that LED back on. Oops. So let's see what that looks like. And we'll go ahead and set this default to true, just so we can go right into that line of code, because we haven't completely set up our button yet. So slept for 2 of 10 seconds. And our expectation is that when it gets to above 10, it will print turning on. So it says turning on, and now we're no longer in that block of code. So that's good. Now, and you see our LED came back on. So now we'll do our button just so that we can debug this. If digital read 3 is 1, then we'll set is kiosk sleeping true. Sorry. And then we'll return. And we'll do serial print line, and we'll say turn kiosk is going to sleep. And we can call turn no completion for some of these methods in this little IDE. So turn kiosk off, I want to call. And then down here, we're calling turn kiosk on. So let's cycle back. Let's see. I didn't spell digital correctly. No big deal. Okay, ooh, nice. So now we're in a gnarly loop. Now, why is that? Let's just go ahead and stop it. Turning on, turning kiosk on. When it's turning on, it should set kiosk is sleeping to false. So then we shouldn't come back into here. What does turn kiosk on do? So all it does is pull that 1 pin high. And it says kiosk is going to sleep because okay, so well, one thing we need to do is that when we are turning the kiosk back on, we need to set our counter back down to 0. So that's one thing. So it was never resetting that, so it would always fall back in here, and then it would keep looping. But for whatever reason, digital pin 3, which is actually, we should be reading digital pin 5. Okay, so we were reading the wrong pin, and so it was always 1. So the kiosk was on, and this was true. So then we'll put it back to sleep, and then this would be true, and then it would fall back into here because we didn't reset the counter. So it's a sort of gnarly infinite loop. So we'll play this again. That should be fine. Okay, so now we are back on. Now let's put it to sleep. So let's say, again, this button represents the kiosk via Bluetooth saying turn me off. And so as I held down that button, it looped multiple times. So we probably want to make sure that we turn off and then we delay for a second, just so that it doesn't run this block of code multiple times to give us like all that output, because it's very confusing. So we'll run this. Now our LED is on. So we need to set this kiosk sleeping, we need to default to false. So now it will only pretend to sleep when we press this button. Okay, so it hit the button, you read the button, now it's off, so now it's sleeping for a set amount of time. Now it turned it back on. Now we press the button, kiosk is off. Now it's sleeping again, and then it'll come back on. And that should be about right. That should be about what we want here. And now it's back on. So that's good. That's good. I like that. I like that. That makes sense. All right, so I think that the solution is pretty good. It's always best, of course, to test on real hardware. So how should we do that here with good old YouTube? It's probably something that we're going to have to do in the field, which is unfortunate with the setup that we've got here. I don't love that. The one that we have in the field, let me see if I can pull up a picture of it quick. Just need to kill the screen for a second, find the image. Yeah, here we go. So this is what we actually have in the field. This is real hardware. It's obviously a prototype. Zoom in a little bit here. So there's our Arduino. This is our relay breakout board. And then this is our load. This is the positive end of our load. Here we're powering the actual breakout board. And this is our signal. So this is what we pull high and pull low to turn our load on and off. This is the little voltage sensor that we had, and you can't quite see it that clearly, but there are leads coming out of here, so we're powering it, and then also we have the lead. Well, yeah, we're powering it over here, but then this is the lead that goes directly to the 12-volt battery, so it's reading directly from that device. And I realize I've got this silly logo on top of you there. Then this is our Bluetooth module that's sticking vertically up, so it's tough to see it, but in case you're curious, that is about what it looks like. Got some resistors in there, so this goes to here, then it goes back over here, and then it connects to this is very crude, but it's how it is sometimes. See if we have one that's not hooked up. We should have one laying around here somewhere. Not conveniently located, though. Anyhow, so this is by our RX pin, I believe. And then TX, it doesn't really matter. Yeah, so this would be positive. Yeah, okay. So this is positive, negative, TX, oops, RX. So we're going to have to do a little bit of engineering out there in the field. Let's see, these paths here, this goes, they look much bigger than they are, but this is an actual reset pin. So Arduino comes with a little reset. And we can kind of simulate that here. We'll simulate it in this one, I think. So if I guess you can't copy and paste. Let's do another push button. And all we really want to do is, I guess this is we don't want to read it because we really just want to connect two wires. We want to connect this reset pin and we want to short it to ground. And so then that should reset the whole thing. So play it. You'll see it prints out hey every time, which means it's almost like you're unplugging the Arduino and then plugging it back in. And it has the exact same function as this button here. And you can see I can press this button and press it and press it. Again, point being there is so we have an actual push button on the outside of our hardware device, and that's in the event that for one reason or another it's shut off, right? That would obviously be bad. Now I'm trying to figure out a way so that you can see this in real life. I can't promise anything, and I could have come better prepared, but maybe if we come in and start up the Android, start up Android Studio, if we can kind of show what that looks like. Again, there's a lot of crude stuff in here, but I think it could be interesting. So if you'll give me a moment, I'm going to run to the restroom. Be back. We got about 40 minutes or so, so I'll be back in quick 5. Okay. So the next order of business is to, and I might have started on this already. Um, so yeah, we got this method called check for shutdown. And so it's essentially us going and getting the calendar, getting the hour of the day. And if we're within this, I'm not finished yet, but if we're within this range, then we want to wake up. If it's the hour is equal to, this will be 4 p.m., whatever the local time is. If we're in that hour, then send wake up in, send a command that says wake up in, and then it's delimited by this colon. And then this will be uh, 1 hour. So 60 times 60, right? We'll, and then, yeah, that'll send it back down. And then we need to probably look for some kind of acknowledgement. Or we just continuously try to send it for the entire hour, 16th hour. So on the Arduino side, we need to listen for it and react to it. So I'm eating some food, as you have to. We have a workout today. We've got practice with our run team. Um, so I'm not really sure what the workout's going to be, but it's probably going to be about 30 minutes of running. Did have a successful run over the weekend. I was successful in 5K. We did a PR. 17 minutes and 17 seconds was the time, and we got second overall male in the race. So it was pretty awesome. And the trophy is upstairs, or the lanyard, whatever. So very cool. So if I send this command to the Arduino, what are we going to do about it? So here, it's where we'll handle commands. So we are listening for wake up in. And then, no, this is no longer correct. Sleep count, we're not doing sleep count. We're doing this. So this should essentially be the same bit of code as we have up here. Where we are sleeping. No, we don't want that there. So yeah, sleep counter is set to 0. Wake up in is sleeping is true. Turn it off. Wait just a second. Return true. Return true is returning a value of halt shutdown. That's essentially, if it returns true, then that'll give it an opportunity to perhaps do some cleanup, send some communication out, send some commands to the device before we actually initiate the shutdown. So it should be good. Now this is really hard to emulate because I don't have Bluetooth right now. So one thing that we could do is we could kind of switch cameras here because we do need to do this. So I'm gonna have a docking station here before too long. I'll be able to have more than one USB device at a time, but for today we do not have that luxury. So let's just, oops, how to put it in the right way here. So do that. Say goodbye to this nicer camera for a second. And we will add another camera. We'll do this camera. There we go. Okay, good enough for now. Test, test. Okay. That ought to be okay. Audio. Put it in for a second. Yes, and then this is our, so you can see it. So this is our tablet here, and it's got black screen because I've got some tape with the camera. Essentially, really washed out here. We're doing some different work. We're trying to work with some of the exposure stuff in the camera. Probably the last time I was working on this, so it's kind of stuck in this awkward state. But for now, cover it up. So send the command. Well, send the command. If it's a key value command, because it has an index of colon here, the index of colon is more than -1, then it's a key val command. It's a key val command, and we want to get the index of that colon. And then we want to get the actual name of the command, so that'll be everything from the 0th index to whatever the delimiter index is, and then everything after the delimiter index and then to the end of the string will be the actual value of the command. So we now have a key and a value. And so if the key is wake up in, this be a switch statement would be a bit more useful. Then we will run this block of code. So we'll say kiosk. And yeah, right. So we've already been over all this. We'll take the value and we'll convert it to an integer because that's what we expect. We'll say kiosk is sleeping. We'll turn it off. And to simulate this in the real world, we should hear a click off the relay. So, but before we get there, we're going to have to get this over to the Arduino. So let's do that. Yeah. We will get this into the Arduino IDE. We're going to make sure that all of our pins are set correctly, because there's a different pin layout here than there were in the emulator. So we've got pin 3 is the relay pin. The RX pin for our Bluetooth, we really need. Well, we could just set it. Pin 5 is not going to matter because we're not doing anything with it. So, okay, yeah, that device doesn't use this, so we'll set the device. Now we can upload. Put our serial monitor. Oh, programming not responding. Okay. Well, one bad board on the table here. Let's see if this is any better. There we go. Okay, so this is a good one. So I'll just switch it real quick. Okay. There we go. That feels better. There we go. So pin 5 is high for whatever reason, but we're not going to use that right now. There we go, looks better. So because there's nothing hooked up to the voltage sensor, it's just going to give random values, and I don't really understand why. Sometimes they're, as far as I can tell, they're pretty random. But it's kind of nice because it sort of helps us emulate a real world example. Instead, there's always going to turn the device off. So you can kind of ignore that for now. You should be able to send commands to it. It's not very easy. How do I want to do that? So we basically want to initiate is kiosk sleeping. And the way to do that is to send that command. So probably going to need to, and then you can't read that. There we go. We're going to just update the app to send it when we tell it to. And every time, this is called fully kiosk. It's a great app if you need to write an Android app and not have to worry about any of the kiosk, code, like getting admin permissions and all that other stuff, and then like be able to connect it to a backend. All that's done for you. It's totally worth the money. It's been kind of impossible for us to do what we do without it. It's not even a question. So if I go to, I've seen it do USB debugging. The reason being is, I don't know, it turns off every time for some reason. And so we'll just start up the app without a kiosk shell. And do this. There we go. So now we can run it. All right. So it's hard for you to tell, but we have a small, it's actually possible. We have a small icon here that says that we're connected to Bluetooth. And then another icon here that says we're connected to Wi-Fi or connected to the internet. So now we can compile the app, we're running it. Let's see if we can get, where's logcat? Got logcat logs. And we'll debug. Let's do, we tag those first, right? Yep. We'll do command. Let's say we're in Kotlin here. I love Kotlin. I knew Java better just from school because that's just what they teach. But it gets the job done. So we can say hour 24. There we go. We'll just do that and make sure that this is getting run. We can also set up a breakpoint if we really want to. Now we compile. See what we get. Any day now. Brightest down so y'all can see a little bit better. All right, so this gets called and it's hour 15. So instead we do, so this hour 15, then recompile. And then we'll be able to see what happens. So while it's happening, we can pull up the firmware or the serial monitor here. Okay, yep, whatever, it's hour 15. And then it says, ooh, here we go. Kiosk is off. Kiosk is sleeping for that many seconds, which is an hour. So obviously it's going to sit there and count for an entire hour. So I didn't hear the click. So I'd like to hear the click. We want to make sure that our kiosk is on. Which is what we do here. And then I got the kiosk off, right? Wake up and turn the kiosk off, okay? Okay. Kiosk on. Let's just get it running. So, okay, so every time there's a serial read, then we will check for that. Now, the next question is how often is like a call point? I hope the audio isn't terrible. Hmm. What would be great is if I had an LED to light up. Is there an LED? No. Well, let's get out here with the multimeter. So in our reference image, we have this exact same relay. Let's see. So let's orient myself. Okay, that's what I thought. We've got these. I'm gonna put the multimeter on these two pins and check the resistance. Now there should be basically no resistance. Or I'm sorry, a lot of resistance because it should be off as it says. So if I kill the app, like that, so it'll stop sending that message to the Bluetooth module. And then I reset it. Okay, so now it's on. And the way that we know it's on is because we get that reading. If it was off, nothing would be connected, right? None of this is connected, and it says OL, which I can't really remember what that means. But if you can see if these two probes, hopefully you can see, if these two probes are connected, you can see that we do have some numbers up here, right? So they're connected here. Now they're not connected. Oh well. So if you get some numbers, if they're connected, wish I could have a camera view here, but I don't. So then right now they're not connected. And that's because we hit our over discharge. So if we reset, hopefully we'll hit over discharge again. So right now we're connected. We're almost at over discharge. Should be turning off. And I heard it turn off. You probably couldn't hear it there, but it did in fact turn off. So now the thing to do is we're going to reset. Okay, so now we're reset. Where it's over voltage, I'm going to restart the app and it should turn it off. So we're connected. Oops, I didn't start the app. Connected. And then we just turn the kiosk off, and you can see in the output there, it's because we got the shutdown command. So now after an hour, which is what it's set for, it'll turn back on. Now we're gonna be nice to ourselves and just do 20 seconds. Just like that. It'll recompile. Reset the Arduino. We're connected, we're on. Okay. Second here. Get the output. Now it's sleeping for 20 seconds and then it'll turn itself back on to where, let's reset this one more time. So it's turning itself off. Eight, 7, 6, 5, 4, 3, 2, 1. And it's on. And that's really all we needed to do. That was it. Like, if we wanted to go a step further, we had a mechanism on the back end. I don't even see that anymore. We have a way to send and set values from our back end. It's sort of convoluted. We actually went to a consulting firm to get a lot of this built. We used to, and we still do have a web version of this, and I'm sure in a different stream, but the web version of this was great, but it was just a little bit too much to handle for some of these other devices. And so we wanted to have an app that was a little bit more, use a little bit less power. Anyways, get to that later, but we can set these values like how many seconds we want to wait, before we wake up. And that's probably the next step here, is to be able to set that from the back end, because a device being off for an hour can be kind of a long time, because if you want to do anything, there's nothing you can do about it. Like, it's going to be off for an hour unless you want to go out there. Unless in an hour, then you're not going to hear back from it until it wakes up. So, and then these devices, again, they will, when they get plugged in, they will automatically turn on, and then they will open up the app immediately. So there's no login process at all, which is kind of the point. So that's definitely the next step. And so what we'll have to do is when we go out to the field, and I'll try to record some of it when I go up there Wednesday morning, we will we'll sort of show the process, try to document it as we go. And try to get the stuff deployed out into the real world. And then, in the meantime, we'll see about doing some more testing, making sure it's doing exactly what we want. And we can test some of the resolve of this here by opening up the kiosk app, making sure our settings are right. And I realize that you can't quite see this. Okay, so this app, it would seem, turns off developer settings. So let's see. Yeah, so the kiosk, we want kiosk one right now. And I know you can't see. I just want to make sure that the app comes up when it restarts. Just restart it now. That's one way to test. So it's a start screen. And then it unlocks. So we can start kiosk mode, and then we'll do it again. Just a little prompt saying start kiosk mode, and we'll say yes. Now we'll restart, it'll let us. Yeah. So it's online. Now we'll restart. It's restarted. It's unlocked itself. It's opened the app. And it's active. It's launched, and it's in a second going to connect to the Bluetooth module, we would hope. And it's connected by this blinking red light. And also there's an indicator on the screen. Okay, now it's connected. Guess it can take a while sometimes. So let's simulate basically what we're doing, which is power failure. Just do that by unplugging it and plugging it back in, which is literally what the relay is going to be doing. So, cool. Put on power failure. Now, I know that this works pretty well because we have one job site out there that is run, the whole thing is run by a generator. So we plug it into the job site trailer, which is kind of those trailers that you see on a job site. And so they turn the generator on, it turns all the power on, so it turns the kiosk on, jumps into kiosk mode. And then they do that every single day. So we know that we're not hurting things too bad, though I'm not completely convinced that that's okay to do repeatedly, indefinitely. So now we'll plug it back in. The Bluetooth module is searching. You can see that blinking red light. Kiosk is turning on. Okay, and then it'll be opening the app soon. Open the app. And it's searching for Bluetooth now on the device. And we're connected. So that's probably about all we can do for this moment. The next step would be to actually get a device plugged into this relay so it can manage it on its own, but this should be good enough for now. And we're running up on time today. We got many things to do to get ready for the wedding, but I think we made some pretty good progress. We didn't have to do too much, but we did get some firmware done. We sort of explained some of our proprietary hardware that we've been developing, showed some code, wrote some code, tested some stuff, sent some commands back and forth over Bluetooth. Yeah, I think that this is about it for us for now. And then hopefully the next time I see you, we will be out there deploying the stuff that we've got. So let's go ahead and cut it there. Thanks everybody for tuning in. If you've made it this far, you have learned, a lot more about the company and what we do and how we do it than you would have otherwise. Hopefully this has been inspiring. Hopefully it kind of gets you in gear to go and do your own thing. If that's what you're doing already, keep doing it. Keep grinding. Be sure to take care of yourself, take care of your family, and get the job done. So until next time, probably later this week, we'll see you then. All right.